Welcome to our help video on 3B10, determining the atomic mass. Be sure when you're doing these problems that when you are given something in a percent form, you have to convert it back to decimal form by dividing it by 100, which is the same as sliding the decimal 2 places to the left. In these problems, you will multiply the mass of each of the isotopes by that percent expressed in decimal form. You add them all together, and you will find the atomic mass. Please be sure that above each expression of the isotopes that are contributing to this atomic mass, that you list the name of the respected isotopes. That is how we do it in this class, and it is a good practice to do. Also, anytime we do problems in here, you must show the entire setup. A lot of you want to just list the answer, and you want to do all the work on your calculator. Well, that will not count for any points. The answer only counts if you show the entire problem. That is just the way things are done in chemistry. In our first problem, we are told that neon has two isotopes. Neon 20, that's the neon that would have 20 particles in the nucleus. 10 of them are protons if you look on the periodic table, which means 10 of them are neutrons. The other isotope is neon 22. That means that neon has 22 particles in the nucleus. Only 10 of them are protons since it's still neon, which means that isotope has 12 neutrons. And they want us to calculate the atomic mass for neon. Neon 20, 90% of all the neon atoms are neon 20. Its mass is 19.992. Now keep in mind, neon has 20 particles in the nucleus. Each of those particles, the protons and neutrons, have a mass of more than 1 AMU. So we would expect neon 20 to have a mass above 20. It has 19.992. That is a result of something called mass defect, where some of the mass of the protons and neutrons is converted into the binding energy to hold that nucleus together. Einstein's famous formula, energy does relate. Energy equals the mass, m, times the speed of light squared. Mass is related to energy. Neon 22, only 10% of the neon atoms are neon 22, having a mass of 21.991. Since 90% of the neons are 19.992, we would expect the atomic mass, which is going to be the weighted average of the two masses of neon 20 and neon 22, we would expect the answer to be closer to 19.99 than 21.99, since only 1 out of 10 are neon 22. So here we go. Set it up. What's the atomic mass of neon? That's what we're trying to find. Let's talk about what neon 20, how much of the average or the atomic mass of neon is contributed by neon 20. Well, neon 20's mass is 19.992. We write that right there, and then we take the percent and convert it back to the decimal form. We could take 90 divided by 100, which is 0.9, or we can slide the decimal 2 to the left, which is the same thing, 0.9. If this has 2 zeros, we write the 2 zeros as there, we write them there as well. You don't get rid of zeros because we use those zeros to decide how many numbers to keep in our final answer. In other words, how to round our answer. Neon 22 is the other isotope. 10% of them are neon 22, but we take 10 and divide it by 100, which is the same as sliding the decimal 2 to the left. We get 0.100. And the mass of that one's 21.991. So on our calculator, we could take 19.992 times 0.9 hit equals, and then add it to and use parentheses, 21.991 times 0.1 parentheses, and then hit equals. You should see, if you're plugging your numbers in your calculator correctly, 20.1919. Now, how do we know where to round the answer to? We look to see which number in the calculations had the fewest numbers. This one has 3 numbers, 0.100, that's 3 numbers. 0.900 is 3 numbers. So we round our answer to 3 numbers, 20.1919 that 9 would round that up to 0.2. In our second problem, we're dealing with chlorine. 75.53% of the chlorine is chlorine 35. You're like, but they didn't write an atomic number here. Well, this is another way of expressing which isotope of chlorine we are working with. This is chlorine 35. All chlorines have 17 protons, so when they're doing these problems, they don't always show the 17 there. But to have this in correct nuclear symbol format, we would have the symbol there. They're just trying to show you which isotope we're working with, which is chlorine 35. The mass of chlorine 35 is 34.969. Again, less than the 35. But that's because some of the mass is converted to the energy to hold the nucleus together. The other isotope is chlorine 37. 24.47% of the chlorines are chlorine 37. Its mass is 36.966. They want the atomic mass of chlorine. That should say chlorine right there, not neon. That's a mistake. That should say chlorine right there. They want the atomic mass of chlorine. Chlorine 35 is this one. Its mass is 34.969. We put it right there. 75.53% of it is that, but we want this in decimal form. So we take 75.53, divide it by 100 to put it back in decimal form, which is the same as sliding this 2 to the left. That becomes 0.7553. Chlorine 37's mass is 36.966. That goes there. We would write chlorine 37 above that in the brackets, because this is the part of the mass that's contributed by chlorine 37. 24.47% of it. Divide that by 100, or slide the decimal 2 to the left to get 2447. We plug this into our calculator by taking, and you can use parentheses here to make it easier so you don't get orders of operation errors, but you could take the 34.969 times 0.7553, hit equals, plus, and now we can use the parentheses. 36.966 times 0.2447 parentheses, and hit equals, and you would get 35.4576659. What do we round it to? We look for the ones used, the number in the calculations that has the fewest numbers in it. That one has 4, that one has 4, so our answer, we're going to keep 4. We'll keep the 354, 5, but that 7 is going to round that 5 up to a 6. Again, sorry about the mistake. That should say chlorine right there, not neon. Notice we have two elements. Our percent should add up to 100%. With two elements, if we take the 75.53 and the 24.47, if we only have two isotopes, 100% of them should either be chlorine 35 or chlorine 37. That's important in our next and final problem. Bromine has two naturally occurring isotopes, bromine 79. It has a mass of 78.918 AMUs, and it is 50.69% of all bromines are bromine 79. The other isotope is bromine 81. In this problem, they're asking for the mass of bromine 81, but they gave us the atomic mass is 79.90. When we did these problems in the past, we were trying to find the atomic mass. On this problem, they gave us the atomic mass, 79.9. So that is going to be plugged in right here. 70.90 is the atomic mass. Bromine 79 is one of the isotopes. 50.69% of it is bromine 79. So we take that 50.69. Divide it by 100 to convert it back to decimal form, which is the same as sliding that 2 to the left. 0.5069. The other isotope is bromine 81. And we don't know bromine 81's mass, so I plug in 81 bromine right there. But I don't know what percent of it is bromine 81. But I only have two isotopes. The two isotopes would make up 100%. 100% of bromine is one of these two isotopes. If bromine 79 is 50.69%, then the rest is bromine 81. 100 minus 50.69 is 0.4931 or 49.31%. So right here, we would write 49.31. We've got to convert that percent into decimal by dividing by 100, which is the same as sliding it to the left. If we take 0.5069 and add it to 0.4931, we would get 100%. Now we've got to solve this. We're looking for the bromine 81. We want to solve this equation to isolate this variable, bromine 81. So the first thing I do is resolve what is in here. I take the 0.5069 times the 78.918. I get 40,0035342. We do not round in the middle of the problem. Always use what numbers you have. We round at the end of the problem. And then I would just bring down this. I haven't resolved this yet. And I can't resolve it because we don't know what bromine 81 is yet. So how do I get rid of 40.0035342? Well, I'm adding it over here. So if I subtract 40.0035342 from both sides, as we're showing here, I'm going to subtract this from both sides. What I do to one side of the equation, I can do to the other. 40.0035342 minus 40.0035342, that would cancel out on this side. 79.90 divided by 40.0035342 is 39.8964658. So I got rid of the 40 by subtracting 40 from both sides. Some people just say, well, if I'm adding it here, I could subtract it from there, and they don't want to do this. That's fine too. However you do it in math class works. Now I have to resolve this. I can remove the parentheses now, since I don't have another operation there. How do I get rid of 0.4931 times bromine 81? You undo multiplication by dividing 0.4931 from both sides. 0.4931 divided by 0.4931, that would cancel out or factor out. 38,8964658 divided by 0.4931 leaves us with 80.91. Bromine 81's mass is 80.91. If you have any additional questions, do not hesitate to email me. Hopefully this video helped. Thank you.